All right, next let's look at how do we find the normal force for an object that is on an incline. Now, if this had no friction, this would obviously slide downwards. And so if I were to make a free body diagram of this right here, I would have the force of gravity acting downwards and the normal force acting in this direction. Remember, the normal force is always going to be 90 degrees to the surface. Okay, always point straight out of the surface, 90 degrees to the surface. And so that would be what my free body diagram looks like if I were to kind of determine, well, what would happen when I turn this up? If I were to take this vector and place it here, add them up, you see I get a net force acting in this direction, which is really the direction in which this block is going to move. We can determine what the normal force is here, because if you look at your angle, this angle would equal to this angle as well. You can see that pretty simply if you were to use some angle identities. That this is theta, this would be 90 minus theta. Minus 90 gives you theta again up here. So that is two components of this force. There's force of the normal force component in this direction and the normal force acting in that direction. When we were to look at this, we generally place our axis this way because that is the direction of motion, and it's far more convenient to have our coordinate system aligned in the direction in which the object is going to move. So if I do it that way, I can see that the normal force is all in the y direction, but gravity now has a component in the x direction and a component in the y direction. This is my component in the y direction, that's my component in the x direction. Remember, I have a new coordinate system that is inclined in this way. So if this is theta, then this will also be theta, because this is theta, that's 90 minus theta, so that makes that theta because this is 90 degrees. And so you could see that this object does not accelerate in this direction, only in that direction. So some of the forces in that direction must equal 0. Well, this component of gravity is mg cosine theta, because this is mg. So this part here would be mg cosine theta. And so we could see that the normal force, I'll use Fn, is going to equal to mg cosine theta. And so that's how you would find what is the normal force for an incline. And you could see that it is less than what it was before. The normal force becomes lower as you increase this angle. And obviously, if you see that when you get to 90 degrees, then Fn is just equal to mg times cosine of 90, which is 1. So then Fn just becomes mg, which means that the object would basically be free falling, and that's what you would expect to see the force on it when it's free falling. Okay, so that's how you simply find the normal force on an incline. You can pretty much eventually end up just memorizing it, that it would be mg cosine of theta, where theta is the angle of the incline.